Good morning, everybody. I hope everybody's doing well. So this video is about current electricity, and as we said before, current electricity is the electricity that is moving. So for example, if I have battery, the electricity moves in my battery, goes into the light bulb, and then it goes back to the battery, and then so electrons keep moving like that. It's not like static electricity. It's a moving electricity. So we're just going to find out how can I create current electricity? What are the components of a circuit which electricity can move? So I call this a circuit, which we're going to study. So let's go back again to what is electric current. And we said electric current is the flow of electric charges. What are those electric charges? They are electrons. Okay. Can protons move? Never. Can neutrons move? Never. The only thing that can move inside the wire and create electricity are electrons. So you have to know which ones can they move? Only electrons. The protons and neutrons inside the nucleus, they're so tightly packed they can't go anywhere. Only electrons are free to move, and only electrons of a metal. Remember when we talked about chemistry, we said metals are the ones that they have 1, 2, or 3 electrons in the last shell. Okay, so therefore, electrons of a metal, they can move and they can create electricity. Can non-metals create electricity? Never. That's why all your wires are made of metals, not non-metals. You never get anything, a wire made out of, for example, fluorine or hydrogen or oxygen or nitrogen, like they're gases. They can't even create wires. All right. So what is an electric circuit? Okay. An electric circuit is a pathway. So if I'm just going from the battery, this was my battery, going all the way to the light bulb, right? Light bulb. And then go back home to the battery. It's like when you go to school, which you don't go right now. But if you did, you go to school and then you come back home. This is called a path or your road, right? So when I create a path for electrons to move, I call that a circuit. So this is a circuit. Can I have a path for static electricity? Not really. So here, electrons movement or flow is controlled. Controlled means I know it will go from here to here and then come back. Goes from here to here. This is my electricity. And then it comes back. So it's controlled. Can this be controlled? The lightning? Can you just say, well, I'm going to turn my TV on. Tonight is the lightning. Not really. When you touch the doorknob and you get zapped, it hurts your finger. Can you control that to charge your phone? Not really. Even though this is electricity as well. So what is the purpose of an electric circuit? Why do I need it? Why do I do that? Why do I connect a light bulb to a battery? Because what it does, the energy from the battery changes to what? To light. So why do I want a circuit? A circuit, whether you have a light bulb, whether you have your heater, mixer, your bell, the doorbell, what they all do, they convert electrical energy into another forms. So all of them are electricity, but here I get light. Here I get heat. Here I get mechanical energy. That means something that turns. Here, mechanical energy means mixing, like a motor. Anything that turns in circle, we call a motor. And in bell, I get sound. So you can see how electricity changes to light. Electricity changes to heat. Electricity changes to moving. Electricity changes to sound. So when you watch your movies and you're listening to your music, you need electricity. That's why you charge your phone. So it's going and converting to all these components. That's why I need a circuit. Without a circuit, if you don't plug in your heater, you're not going to get heat. So that's why you need a circuit. So what are the parts of the circuit? The first thing you need in a circuit is the source. This electricity has to come from somewhere. Source means where is it coming from? So you can get electricity from battery, like your remote control, your TV remote control, or even your phone has battery that is charging. You charge the battery of your phone. Or you can get the AC power, like we call this an outlet. So this is called the outlet. Where's the outlet connected to? This electricity comes usually from, the hydro places, or the companies who make electricity, usually from Niagara Falls or something, from water. They come to your house. But this is called the outlet. So you can get it from the battery. You can get it from the outlet. And then sometimes you can get it from the sunshine or the light. They call them solar. Solar means sun. If you ever have used a calculator that needs no battery, usually if you look, the calculator uses solar cells. That means they use the energy of the light in the room, and you never have to charge your battery. It will always be, okay, as long as there's light in the room, your calculator will work. The second part of an electric circuit, we call it load. So what is a load? Load is anything that changes electricity to something else. So the key word for load is, you can say anything. Sorry, I'm doing my best to write with the mouse. You can hear it. Anything that uses electricity. So your phone is a load. Your TV is a load, right? The flashlight here is a load. The fan, the motor is a load. The toaster is a load. Your fridge is a load. Your computer is a load. Anything that uses electricity, we call it a load. So if I ask you, can you name 5 loads? You can say flashlight, motor, my computer, my fridge. Those are called loads. Good. The third part of a circuit, we call it connectors. What's a connector? Wire. What is it made of? A wire is made of 2 parts, right? So this is your wire. Inside, this is a metal, right? A metal is shiny. Usually we use, most of the metals they use usually is copper. I apologize for my beautiful writing. It's hard to write with a mouse. So metal is inside the wire, and we call that a conductor. Don't know if you remember that. So all metals are conductors. What does that mean? They are good for electricity. They conduct. electricity. So they're all good for electricity. Conductor, good for electricity, good. This part, the black part that you can see here, it's called insulator. Insulator, right? Insulator is a non-metal. So non-metal, I'm just going to write the short form, non-metal. So plastic. So outside here it's plastic. Okay? Insulator, not good for electricity. Because if you touch the metal with your hand, you get electrocuted, right? That's why they put the plastic around it. So if you touch it, you don't hurt yourself. So all wires, inside metal, outside insulator to protect you. But what they do, they connect. They connect the light bulb to the battery, to your switch, everything. Okay? So third part, connectors. The last part, it's called control device. Now, if I want my light to be on in my room, I don't want to go to the ceiling every day and unplug it, right? So what I have to have, a control device. That's why when you get to your room, you have a switch. You have this kind of switch sometimes. You barely say this. This is for school switches, but you're familiar with this one. You go in your house, you turn the lights on and off. When you don't want it, you turn it off. So if the switch is closed, now you can see here is closed, this is on. So you turn on the light. It looks like this. When you turn off the light, the switch has to be like that. It's open. So open, it will be off. Closed, it will be on. Do I have to have a switch? Not really. All I need is wire, battery, light bulb, and I will have it work. But I will have no control. I have to keep disconnecting and connecting the wire. That's too much. Most of the wires in your house are underneath of all the drywalls or the walls. You don't see it. So in order for you to have control, right, control, you need to have the switch on and off. Therefore, you need switches. That's why they call them control devices. Then you will have measuring devices. So you need to measure electricity. And we will get to this in another lesson. But two types of measuring devices. One is called voltmeter. And then sometimes you see multimeter if we were in school, which measures so many different things. So measuring, again, it tells me how much electricity I have, what's happening in my circuit, and then you read the numbers. And we'll practice that too, okay? So measuring devices. So 5 parts of an electric circuit. Do I have to have measuring devices? Not really. So number 1, 2, 3, very important. I have to have a battery, I have to have a load, I have to have a wire, but do I have to have a switch? Not really. Do I have to have a measuring device? Not really. So without the last 2, I still have a complete circuit. But these ones are helping me. Okay, so we're just going to go over the booklet that I posted for you, and we're going to take it up. So the word here, electrons, we already know that. Circuit, again, it's a path. And generator, it's something that creates electricity. So most of the generators in, around Hamilton or in Niagara Falls, and that's how they create electricity. They create electricity for the whole city or many cities, big ones. You either have battery, which is for small things, and then for the big things, when it comes to your homes or workplaces or the stores, we can't have batteries. It's too much. So we need to have generators that they can generate lots and lots of electricity. Okay, so think of all the ways you use electricity each day. You wake up to an alarm, so hopefully most of you use it these days because otherwise you can sleep in, right? Clock, radio. You can turn on an electric light. You can use toothbrush. Some fancy people, they have electric toothbrushes. You can make toast in a toaster. You can watch television. You can listen to records. You can use air conditioner when it's not hot yet that much, but they all use electricity. These are all called loads. So clock, electric light, toothbrush, toaster, these are all your loads. Almost every place you go, you find electrical lighting. About 100 years ago, there was no electricity in homes. Can you imagine? Just 100 years ago, we had no electricity. No electricity in schools, no electricity in factories and offices. Just imagine your life without electricity. The electricity that works all your electrical appliances is called electric current. So the type of electricity we see all the time is the one that flow of electrons are there. It can be controlled. It's not like lightning. Electrons are the parts of an atom that have negative charges. There's another part of the atom that has positive charges. They can never move. Protons don't move, neutrons don't move, only electrons. Electrons move along a path, so it's very important, along a path. We call it circuit. That's very important. A circuit means a path, a road. While the electrons are moving, the electric circuit is complete. So these words are very important because if the electrons are moving and everything is okay, we call it complete. If the electrons stop moving, the circuit is incomplete. So if you have switches, if the switch is closed, then your room is nice and bright, the light is on, your circuit is complete. When you turn off the switch, then your circuit is open or incomplete. So what I want you to do, I want you to connect these two with the two words. This will be open. This is closed. So if I say circuit is complete, another word I can use for that is closed. Okay? If I use the word incomplete, another word I can use is open. Some of our electricity comes from batteries. Electrons move from the negative terminal, again it's very important to know, moves from negative terminal to the positive terminal. Now you say, oh, what is that? So if you buy a battery or dry cell, if you look at it, there's a plus sign and a minus sign. That's how you put them together, right? So negative terminal means this side of the battery. Positive means this side. If you have a circuit, electrons always start to move from the negative side. So they're always moving this way, and then they come back to the positive side. Okay? Like those small batteries, like the ones used in flashlights, are called dry cells. Most of our batteries, most of our electricity comes from machines called generators. And generators are the ones that produce big and large electricity, not small electricity. Every year the world uses more and more electricity, therefore more and more generators are needed. So what I want to show you here, that in science, this is called a dry cell. So if I only have one, there's one here, just one, that's a dry cell. When you have four, That means all of these batteries connected together, these little dry cells. I have 1 dry cell, 2 dry cell, 3 dry cell, 4 dry cells. Then I call that a battery. So, you know, you're all used to the word battery, and we think battery is 1. But when I have 4 of them together, that's when I have battery. Otherwise, I have a dry cell. So 1 is a dry cell, just this 1 is a dry cell, okay? And then 1, 2, 3, 4 together, I will have a battery. So every time you have more than 1 dry cell, we call that a battery. So battery is made of 2 or more dry cells, okay? What does a dry cell do for me? It changes chemical energy, because inside the battery there's a whole bunch of chemistry stuff, chemical stuff, and it changes to electrical energy. And dry cells, they come from many sizes and different strengths. So you might have AA battery, AAA, you know, D cell batteries, so many different batteries. If you go to the store, you want to buy them, they come in many, many sizes and strengths, right? But just the key word is 1 is dry cell, more than 1, it's called battery. And if you look at the picture here, inside there's carbon. If you ever break the battery, you see this little black and, you know, very pasty stuff, just like toothpaste. And then the outside, if you scratch it and those pictures come off, you'll see a shiny zinc material. So the outside is zinc, inside is carbon. Now, these are called symbols. Now, why do I use symbols for electrical devices? You know, we went over all the components of a circuit. Is because I'm lazy. I don't want to draw everything. So instead of drawing the whole picture, this is a symbol. Symbol is a symbol. This is a symbol. Instead of me writing number, I put this symbol. What is this symbol? Question mark. What is this symbol? Hydrogen. What is this symbol? Chlorine. So if I want to show 1 dry cell, this is how I show it. 1 little line, 1 big line. The little line is the negative terminal. The big line is the positive terminal. Okay, so if I have 2 dry cell, 1 minus and then 1 plus in here. Okay, so 1 minus plus, again minus plus. So the big line, it represents, so remember the battery here, I'll draw another one, right? This is a positive side, that's a negative side. So the negative is a tiny small line. The big positive, it's a big line, okay? Minus, plus. So that's how you know it. And these are symbols for all the other ones that you can see in here. And we'll get to it in a minute. So then this picture says, look at this picture, and then remember what we said. These are called loads. Another name for loads, appliances. Appliances or load means anything that uses electricity. What do I see here? I see a radio. Uses electricity. What else do you see? You see flashlight. Right? Flashlight. What else do I see? I see a mixer. Right? I see a clock. So you can name the other ones, you know, this is a fridge and this is a mixer, this is a toaster, right? So how many other devices can you call? Like maybe you can say my TV is another load. You know, your phone is another load, right? Your computer is another load. Your computer is another load. And What else? What else? What else? We can say the toaster again. The toaster is a load. That's an A. It's a very ugly handwriting, but it's best we can do. Okay, so everybody's clear as what is a load. Load is anything that uses electricity. Okay? Now, if you look at this picture, it says, is this circuit complete or incomplete? Remember, open, so the switch is now open. And if the switch is open, there's no electricity. So no light. So you say it is incomplete. The circuit is incomplete. Incomplete. Are the electrons moving? No, sorry. Circuit open, no electricity. Does the bulb light up? No. Okay, no light, nothing in here. Now, unlike that one, look at this picture. This is my dry cell. Do you see the negative terminal? It's very important that you pay attention. This is a negative terminal. Electricity goes from negative, and this time the switch is closed. So therefore, it can go from here to here, goes in here, and then it comes back up, back to positive terminal. So you can see the light in here now. Nice and beautiful light shining, right? So we can say, is this circuit complete or incomplete? I'm just going to circuit it because it's easier to write. It's complete. Another word for complete is closed. So if my circuit is closed, means it's complete. What really means, it means all the components are connected. And if there's a switch, the switch is closed. Electrons moving? Yes. The light bulb lights up? Yes. And it says electricity goes from minus to plus. Draw arrows, and it's already been drawn for you. So it always goes from negative to positive. Okay? Now let's take up this fill in the blanks. In static electricity, electrons do not move along the path. That's what static means. And static means they do not move along a path. Like a lightning can never work. So it cannot move along a path. Right? So let's just cross that one. In current electricity, they move. They move along a path. So I have a circuit along a path. So that's a circuit. So they do move along a path. The path along which electrons move, it's called, what's the path called? Circuit. So again, another word for path, circuit, right? So I'm going to put that in there. Electrons do not move along a circuit that is, electrons do not move along a circuit that is incomplete. Do not move, the circuit has to be incomplete. Another word for that, open. So you have two choices to use, incomplete. So if you're doing your online quiz and it says open, they mean the same thing. Incomplete or open means no electricity. Electrons do flow in one that is complete. So what's another word for complete? Another word for complete is closed. So if your circuit is closed, then the circuit is complete. That means I have electricity, means there's going to be light or anything else that you use. Electrons leave a dry cell through the negative terminal, right? They go from negative to positive terminal. And negative means simply minus, right? Minus. Return, they come back to positive terminal. Positive terminal. And another word for that, plus. Large amounts of electricity are made by generators. Remember, if I want lots and lots of electricity, I need to have a generator. I cannot create that electricity by my battery. No one wants to light up their house with a battery. So we need generators. Portable electrical devices are powered by, the word is dry cell batteries. So dry cells. Now, what does portable mean here? Portable is something that you can carry. Like your phone is portable. You know, you might have small radios, it's portable. Your toaster, like, you know, things that you take all over the place with you, your computer, your laptop, that's a portable device. Okay? So now here in these pictures, we're going to just write down. What does this symbol represent? A light bulb. So instead of me drawing a real light bulb, I use this symbol. This one is a motor. Motor. This one is one dry cell. One dry cell. One dry cell. This one is switch open. Switch open. This one is switch closed. Switch closed. All right. And this one is two dry cells. Two dry cells. And this one is just wire. And this one is any appliances. So sometimes, you know, they call it resistors, but in here in your book it says appliances. Okay, sometimes they heat up, like the heater, the fridge, or anything like that. These are the symbols. So that's what I use to draw a circuit. Okay, so you have to memorize these symbols. You should know them and practice during the quiz. So here it says draw them. So one dry cell, again, this is how you do it. One little line, one big line, and then you draw two lines. The little one is negative side of the dry cell. The big one is the positive. Two dry cell, one little line, one big line, one little line, one big line, and that shows two. Minus, and this is plus. Minus, and this is plus. Okay? Wire, light bulb, you can try the little thing like that. Sometimes there are some different variation. I don't know, like you might have a light bulb like that. Different versions of light bulb available, but this is one. Motor, you draw a circle, you write M, you put a line this side, a line that side, and two lines like that. Open switch, you gotta draw two lines with two dots like this, and then you draw a line like that. That's open. If I have two dots, okay, and then draw the line like that, that's my switch closed. And appliances are going to be having teeth, just like teeth, like that. Okay? Good. So now we're going to look at this matching column A and column B. Flow of electrons is the path of electron. Which one was the answer to? Flow of electron. It's going to be current, electricity. Remember, current means flow. What's a circuit? Circuit is a path. Okay. Minus terminal is where the electrons leave, right? It's the minus terminal of a battery, leave. Plus terminal is where they return. Light bulb is an electrical device. What's another word for an electrical device? Load. Okay, load. And now, electric current is a flow of electrons. True or false? True. Static electricity lights our home. False. Static electricity cannot be controlled. It doesn't have a path. Most of our electricity comes from generators. True. The path of the electric current follows is called circuit. Very good. True. Electrons leave a battery from the plus terminal. False. They always leave from negative terminal. Electrons return to a battery through plus terminal. That's true. Inside a battery is zinc. That's false. Outside is zinc. Batteries give us static electricity. That's false. They give us current electricity. Generators make electric current. Very true. They give us electricity that moves along a path, wires. Electrons stop moving in an incomplete circuit. That's true. They stop. If it's incomplete, no electricity, and that's true. So, and now I'm going to show you how to draw a circuit from the components. So here I have one dry cell, one little line, one big line. Okay? And then one open switch. So what I'm going to do, I'm going to draw that little dotty thing in there, another dotty thing in here, and there's my open switch. And then I go little light bulb. I mean, you guys can do a better job than me. I'm using a mouse. And then here's my circuit. There's the negative terminal, and there's the positive terminal of my dry cell. Okay? And these are all wires. So wires are all around connected. So again, this is your dry cell. This is your switch. This is your light bulb. And I don't know if you guys can see it. So this is your dry cell. This is your switch. This is your light bulb. And this is your wire, right? So if I could have an arrow, and if the electricity was flowing, it will go from negative all the way here. These are arrows I'm drawing to positive. Okay. So the switch here is open, therefore no electricity is flowing. All right. So I'm going to draw another one. One dry cell, one little line, one big line. One closed switch, again closed switch, draw your two little dots in here and then connect the dots. That's a closed one. If I don't connect it, that's open. If it's connected, it's closed. And then two light bulbs. So I'm going to draw two little things like this. That's two light bulbs. So there's one light bulb, there's another light bulb, and then go back and connect. So that's a circuit that uses symbols. Okay? So now, again, electricity moves from negative. That's how you draw arrows. Okay? And then it goes back here. So this time, switch is closed, so you're going to get light. Nice and beautiful. So here, switch is closed, therefore the bulbs are working. So what I left for you, a practice sheet, okay? So you're going to draw these circuits yourself and practice. Even if you can't download the paper, put a piece of paper in front of you and draw it. Then I'll take it up tomorrow. You can compare yours with mine to make sure they're correct. Okay? So that's the lesson for today, that I basically take it up, like I took up the booklet, and for today I want you to practice all these circuits I posted, and then little video to watch, and also I want you to make sure you attempt quiz, okay? The one from day 4, I want you to try it again, because this time now you listen to the lesson. If you're not happy with your mark, try it again, okay? All right, see you guys soon.